Do you know that our planet has scars? One of them is located in North America. This scar can tell us many cool things about the history of Earth, but the most interesting thing is that it could change the appearance of our continents and break our world. But for some reason this scar hasn't done it yet. And that's not even the most interesting part. The coolest thing about this scar is that it might hold a giant source of clean, cheap energy. So let's go to Kansas to find out what it is. So, 1.1 billion years ago, a giant rift formed in the crust of our planet on the territory of the modern U.S. Midwest. It's called Broken Heart. This giant crevice is filled with solidified magma, and from afar, it looks like a real scar. But how did it show up? Broken Heart was an ancient rift valley, a huge geological fault forming elongated hollows in the Earth's crust. It occurred because tectonic plates had moved apart. It's like the details of a jigsaw puzzle that suddenly started to separate. At that moment, thousands and even millions of tons of magma spilled out from the depths of our planet. That event looked like a real apocalypse, lasting about 100,000 years. But then it stopped, and scientists don't know why. If the rifting process had lasted longer, then most likely the continent of North America would look different today, or it wouldn't even exist at all. Right now, this fault looks like a giant horseshoe that stretches from Kansas north to Lake Superior and south to Michigan. But some studies indicate that the fault may be larger and extend even further south, and the width of the fault might equal the width of the Red Sea. After the rifting stopped, the entire valley got covered with hills and trees. The fault itself is covered with a thick layer of sedimentary rocks, so it's quite difficult to track. The most noticeable parts of the rift are in the Lake Superior area. Now everything looks calm and beautiful, but in the past, there were fountains and rivers of lava, earthquakes, a boiling pot on a planetary scale. All that remains of it are deposits of basalt, a dark, dense rock that forms from cooled lava. There was so much basalt that its weight pushed the valley deeper and deeper into the Earth's crust. Even when the eruptions and rifting stopped, the valley continued to sink because of the huge mass of the sediment. Then, massive sections of the Earth's crust on both sides of the valley began to contract, and the pieces of the puzzle slowly started to come together. This led to a large-scale ejection of volcanic material upward, and along with basalt, deposits of copper rock appeared in the valley. People mined this copper for about 8,000 years until the end of the 20th century. The copper mines were eventually shut down, but now it seems the industry is making a comeback. However, Broken Heart is not interesting to people just because of its copper reserves. It holds something more valuable and useful for our civilization. Scientists believe that this valley hides massive reserves of hydrogen, and this substance can help us switch to a cleaner, cheaper, and more efficient energy source. If hydrogen fuel becomes widely available, everyone will switch to it, leaving behind the costly, noisy, and polluting process of oil production. Now, I'll bet hydrogen is a remarkably familiar word to you. It doesn't sound like the discovery of the century, and people have been using it for a long time. On one hand, you're right, but not quite. 90% of the hydrogen produced by humans is used as a raw material for the chemical industry. Hydrogen is used to produce ammonia for fertilizers, methanol for fuel and solvents, and to purify crude oil. Manufacturers of glass, cement, steel, and other metals are considering using hydrogen at their factories for more efficient production. Hydrogen can become an alternative to fossil fuels, that is, oil and gasoline produced from them. Cars, ships, trains, airplanes, and power plants, all of these may switch to hydrogen soon. In this case, production can become cheaper and better for nature, but this will work only if we find open sources of hydrogen. You see, about 95% of the hydrogen we use is produced from fossil fuels. We gasify coal, oxidize hydrocarbons, and extract hydrogen from methane. all of these production methods require energy. But the worst part is that they lead to large emissions of carbon dioxide into the atmosphere. But what if we find sources of pure hydrogen that don't require processing? Then we'll save energy for its production and make the planet cleaner. But where can we find such sources? Scientists say that there are many of them all over the planet, and one of the largest is located in the Rift Valley in the US Midwest. But what's the problem with going and mining it? Well, it's not that simple. To extract pure hydrogen, you need 3 conditions. The first is the source of hydrogen itself, which is quite logical. The second is reservoir rocks, that is, natural containers where this hydrogen is stored. And the third is natural seals, which prevent the gas from escaping. In other words, these seals work like a cap on a bottle. They don't allow the substance to escape. So in general, it's necessary to find where hydrogen is released, where it accumulates, and where it's stored. When these conditions are met, natural resource extraction companies can start working. But how does hydrogen appear altogether? Well, let's go over the basics of chemistry. Hydrogen and oxygen compounds form water. This means you need to split the water into hydrogen and oxygen. This process often occurs in nature. There are many places all over the planet where this happens. Scientists are confident that at least 30 U.S. states have hydrogen reservoirs. And if people detect them, we will accelerate the energy transition to safer and more efficient fuels. Thousands of cars drive around using gasoline. Many of you know the smell of exhaust fumes, that thick polluted air that's hard to breathe. What about electric cars? They must be improving the situation, right? Well, here's another problem. Producing batteries for these vehicles harms nature. The materials used to make batteries are lithium, cobalt, and nickel. Their extraction involves a large release of toxic materials, not only into the air but also into the water. Transporting these batteries also creates a large carbon footprint. Producing a single electric car emits about 4 tons of carbon dioxide. To make up for that, the owner needs to drive it for at least 8 years. That's how long it takes to offset the emissions a regular car would produce. What about reliability and convenience? What will you do if the battery runs out during the trip and there are no charging stations nearby? This problem will be solved in the future with the growing popularity of electric cars. Now, scientists believe that over the past billion years, the Earth's crust has split enough water into hydrogen and oxygen. Our planet keeps this gas in the ground, waiting for us to start using it. According to calculations, even considering all the technologies and production capacities of our civilization, the reserves of hydrogen in the bowels of the planet are enough to supply us with energy for 170,000 years. That's why the giant rift in Kansas attracts scientists from all over the world. Huge quantities of basalt and other rocks can react with water to release hydrogen. And now scientists are looking for places where this material accumulates and is stored.
The floor is lava. Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help." Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the endgame here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first. 7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today, robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical megaquakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from Northern California to Canada. It's called the Cascadia subduction zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields. But nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent, and it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose, and slides all at once, not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate megaquakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia subduction zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this co-seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia subduction zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. The receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, the United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the door and maybe take a walk around your neighborhood every once in a while. The floor starts quaking like it's alive. Books, mugs, and lamps leap off shelves. Your feet slide, your body sways, and you can barely stay upright. It stops for a second, but then it shakes again and again. More than 1,000 times just in one day. This is not how you imagined your trip to Santorini, but it's the new reality. The Santorini seismic swarm started in January 2025. In less than 1 month, there were, get ready for it, more than 20,000 reported earthquakes. For comparison, most cities on Earth go through one small, barely noticeable quake in a year. It all started with small jolts that residents could feel, but tourists might have mistaken for large trucks driving nearby. But by February, things got serious. A magnitude 5.3 quake struck. It's a moderate-strength earthquake, but it was strong enough to rattle homes, break windows and dishes, and terrify the island's population. The Greek authorities declared a state of emergency for Santorini and Amorgos. Thousands of people had to leave their homes. Schools closed, and hotels temporarily evacuated their guests. Santorini is famous for its volcano, the one that blew up in a massive eruption around 1600 BCE and inspired the legend of Atlantis. It's still considered to be active, although there have been no significant eruptions since the 1950s. So it would be logical to blame this monster for all the drama. But nope, these tremors weren't volcanic. Experts said what was happening near Santorini looked like a seismic swarm. It's a series of smaller quakes all happening in the same area. They are happening along faults, which are cracks in the Earth's crust that can suddenly shift when the tension gets too high. Think of the ground like a giant, stressed-out Rubik's Cube. At some point, it twists and snaps somewhere. Near volcanic areas like Santorini, fluids moving underground can sneak into these cracks and make them easier to break. Plus, there's the natural stress from tectonic movements. It's like adding oil to a squeaky, overworked hinge. Suddenly, everything slips. Nobody knows exactly what's coming next. Tracking thousands of tremors isn't easy. Many of them are too small for traditional seismic sensors to pick up. But this time, scientists have their new best friend to help out. I'm talking about artificial intelligence. Thanks to machine learning, researchers can detect patterns in tiny vibrations that humans might miss. This technology has helped a lot to understand the swarm. It lets scientists map which parts of the crust are most active and even predict possible future activity. The AI analysis suggests the quakes aren't random. They seem to be clustered along a fault line near the underwater Colombo volcano. This area has a long history of seismic activity. Even though Colombo hasn't erupted recently, the magma beneath it might be subtly shifting the crust, and it adds tension to the tectonic plates above. It's like a simmering pot. Nothing boils over yet, but the heat is definitely building. The swarm has subsided after a couple of months of constant shaking, but it doesn't mean it's over for good. Even after a lull, another swarm could strike, or a larger quake could happen along the same fault lines. That's why scientists are now studying the data collected from the swarm. If you're thousands of miles away from Santorini and don't have plans to visit, it doesn't mean you're 100% safe from a similar scenario. Seismic swarms like the Greek one happened in the Caribbean, Iceland, and Italy. One of the best documented swarms in history happened in Japan, in a suburb northwest of Tokyo. It was all going on in a town sitting on a seismological observatory, like a secret underground lab for tracking earthquakes. The swarm kicked off in August 1965 with just 3 earthquakes that were so weak nobody could feel them. But things escalated fast, and 3 months later, 100 quakes a day were strong enough for people to feel. On one day, the observatory recorded almost 7,000 quakes. Out of those, 585 were strong enough to actually shake the ground, meaning you could feel a quake roughly every 2.5 minutes. Scientists figured out that the swarm was caused by fluids moving underground, kind of like the Earth's crust, stretching and bubbling. Studying seismic swarms helps scientists predict earthquakes better, understand how Earth's crust moves, and even prepare for future natural disasters globally. For instance, if they can link the patterns of tremors to magma movement or tectonic shifts, they can apply similar models to volcanoes and fault lines in Hawaii, Iceland, or the Pacific Northwest. Santorini is like a living lab where they combine modern tech with traditional knowledge. AI, seismographs, and satellite imaging add to centuries of human observation. The locals who have lived through quakes for generations contribute insights about small tremors, changes in groundwater, and unusual animal behavior. All this helps scientists refine their models. Santorini's swarm has surely grabbed the attention of the whole world, but it's not the only place on Earth with some intense seismic activity. But what makes Santorini unique is its combination of historical volcanoes, underwater fault lines, and the fact that it's a real tourist magnet. The island is not so large, and the effects of even moderate tremors feel stronger and more dramatic than in other regions. In other places, though, even more serious earthquakes, tsunamis, and volcanic activity are regular news, and the people have learned to live with them. Japan is one of the regions on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. There are around 1,500 of these earthquakes each year that are noticeable. Because of this, the people in Japan have learned to live with earthquakes. There's even a law that sets a rule that buildings in the country should be able to handle earthquakes up to a magnitude of 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is not to collapse, but to save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. They even construct some buildings on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot and move up to 5 feet, but it won't collapse. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happened every 500 years on average. But for a long time now, Cascadia has been quiet, and the scientists are getting worried. They think this might be because the area is locked, so the tectonic plates are stuck together and building up a lot of pressure. At some point, a part of the seafloor could suddenly break and move forward by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. This could make the hillside slide and crumble and take down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse. Scientists are hoping that thanks to advanced AI tech and local communities, they'll be able to better predict earthquakes like this and the one in Santorini. This could save thousands of lives. And for now, we must not forget that the Earth doesn't take vacations when it comes to seismic activity, even in places where you go on vacation.
Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way, way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing, because it sits on the African plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking, and the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a cabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay. It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives, when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States like the Klamath and San Joaquin all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle mega floods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain's steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, It was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke two seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh? Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington Event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail. Communication, medicine, transportation, banking systems. Those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today.